China has deployed a powerful weapon into the skies, and even the United States' most formidable ships are not safe. Recently, the growing threats from unmanned aerial vehicles have increased at an alarming rate, and now the United States has finally done something about it. To defend itself against the threats that these aircraft pose, the U.S. has equipped its ships with the deadliest weapons in the world. What are the capabilities of these weapons? Are they formidable enough to protect these aircraft carriers from the growing aerial threats? Join us as we explore the features of some of the deadliest weapons that U.S. Navy ships have been equipped with. The United States Navy is renowned for being the largest and most powerful naval force in the world. With over 90,000 active personnel and around 484 warships, the U.S. Navy plays a crucial role in America's military power and national defense. A vital part of the USN's strength is its fleet of 11 nuclear-powered aircraft carriers, including the advanced Gerald R. Ford class and the Nimitz class. These carriers function as mobile air bases, offering exceptional versatility and combat capabilities to deploy air forces anywhere in the world. Each carrier is supported by a strike group of destroyers, cruisers, and submarines, forming a strong maritime force. The United States Navy's surface fleet includes approximately 70 Arleigh Burke-class destroyers and 22 Ticonderoga-class cruisers, both equipped with the Aegis combat system. This advanced system provides excellent air defense, anti-submarine warfare, and ballistic missile defense with sophisticated radar and missile technology. Additionally, the littoral combat ships add flexibility and speed, especially in coastal regions. Another important part of the U.S. Navy is its submarine fleet, which includes both fast attack submarines and ballistic missile submarines. The Virginia-class SSNs are designed for stealth, reconnaissance, and striking capabilities, while the Ohio-class SSBNs play a crucial role in the U.S. nuclear deterrent strategy. Recently, these warships have been under serious threats from advanced technology like drones and other stealth unmanned aircraft. On October 4, the USS Gerald R. Ford, the newest United States aircraft carrier, set sail for its first deployment amid increasing tensions in the Pacific and uncertainty about the future role of such large ships in warfare. Standing over 9 stories tall and weighing 97,000 tons, 32,000 tons more than the largest Second World War battleships, the Ford is impressive in size. However, it is also fast, powered by advanced A-1B nuclear reactors that give it about 300 megawatts of power, making it nearly 3 times more powerful than current supercarriers. Despite its strength, new anti-ship missiles from China, capable of speeds above Mach 5, pose a significant threat to the Ford and the entire Navy fleet in the Pacific. These missiles could potentially destroy the most advanced ships, similar to how Japan used new attack planes during the Second World War to sink powerful US and British battleships. To battle these new threats, the Navy is employing modern long-range weapons, including universal ship installations, railguns, and lasers, which may change future warfare. Let's explore some of these technologies that would defend these expensive and important ships against aerial threats. Let's start with a special type of gun, the OTO Malera 76. This 76mm gun, also called the OTO 76/62 gun mount, is a naval autocannon made by the Italian company OTO Malera. This gun is small enough to fit on smaller warships. It has a fast firing rate and can use different types of ammunition, making it effective for close-range defense against missiles, aircraft, surface targets, and ground support. The ammo includes armor-piercing, incendiary, and guided rounds designed to target moving anti-ship missiles. It can also be hidden in a stealthy dome. One of the key features of the OTO Malera 76mm gun is its ability to perform multiple roles, including short-range anti-missile defense, anti-aircraft operations, and ground support. The gun's high rate of fire, combined with a diverse range of available ammunition, enhances its effectiveness in various combat situations. The cooling system of this gun utilizes seawater, while fresh water is used for flushing. For its electrical power supply, the gun operates on a main circuit of 4-voltage, 3-phase, and 60 Hz, along with a servo and synchro network operating at 115 voltage, 1-phase, and 400 Hz. This electrical configuration ensures that the gun operates efficiently under various conditions. The OTO Malera 76mm gun has several notable variants, each designed to meet specific operational requirements. The original compact variant features a circular dome and has a firing rate of 85 rounds per minute. In the early 1980s, the super rapid version was introduced, which includes a diagonal dome and a significantly faster firing rate of 120 rounds per minute, achieved through an advanced feed system. This enhanced rate of fire makes the super rapid variant particularly effective in high-pressure combat situations. The Strail system is another significant improvement to the OTO Melara 76mm gun. The Italian Navy favors this variant due to its enhanced capabilities in anti-missile defense, particularly when equipped with dart ammunition, which allows it to counter several subsonic missiles at ranges of up to 8,000 meters. This medium-caliber gun is also effective against surface targets, showcasing its versatility on the battlefield. Another innovative development is the 76/62 Sovrapponte, a new compact and lightweight mount for the 76/62 gun. This system is approximately 30 to 40% lighter than the standard Super Rapid and can be installed without penetrating the deck below. It houses 76 ready-to-fire rounds and is available for sale with or without the Strail system. The Sovrapponte mount was first installed on the Theon de Revel class patrol vessel of the Italian Navy, positioned above the helicopter hangar, emphasizing its compact design. To enhance the gun's versatility, OTO Melara provides a wide range of specialized ammunition suitable for various combat roles. The available types include high-explosive standard rounds, which weigh 6.296 kilograms and have a range of 16 kilometers. Other ammunition types include the multi-role OTO munition, anti-missile projectiles with proximity fuses and tungsten balls for fragmentation, and semi-armor-piercing SAPOM rounds, which have a range of 16 kilometers. The guided dart projectile is designed for engaging maneuvering aerial and missile targets, while the Volcano guided projectile, weighing 5 kilograms, can reach a range of approximately 40 kilometers. The fire control systems of the OTO Melara 76mm gun have also seen significant advancements over the years. Early versions, such as the compact model, utilized the RTN-10X Orion radar. Later, in the early 1980s, the more advanced RTN-30X radar was introduced. This new system is capable of managing various calibers, including 40mm, 76mm, and 127mm, as well as missiles like the Sea Sparrow and Aspide. The RTN-30X system first enters service with the Italian Navy on the Garibaldi cruiser and has since been equipped on numerous destroyers and frigates. The OTO Melara 76mm gun is a versatile and widely adopted naval autocannon that has undergone significant evolution since its inception, with its various models, including the compact, super rapid, and Sovrapponte, along with an extensive range of ammunition and advanced fire control systems. The gun remains a crucial asset for modern naval forces. Its ability to perform multiple roles, combined with innovative design features, ensures that it will continue to play a vital role in naval operations for years to come. Another weapon is the Phalanx CIWS. It is an automatic gun system used to protect military ships from threats like aircraft, missiles, and small boats. It was designed by General Dynamics, now part of Raytheon. The system features a radar-guided 20mm Vulcan cannon that can swivel to target incoming threats. The Phalanx is used by the U.S. Navy and 15 other countries, being deployed on almost all U.S. surface combat ships except the Zumwalt-class destroyer and San Antonio-class amphibious transport dock. Other users include the British Royal Navy, the Royal Australian Navy, the Royal New Zealand Navy, the Royal Canadian Navy, and the U.S. Coast Guard. A land version called the LPWS, or Land Phalanx Weapon System, was created as part of the counter-rocket, artillery, and mortar system. It was used to defend against rocket, artillery, and mortar attacks during the U.S. withdrawal from Afghanistan in 2021. The U.S. Navy also uses the CRAM system, which combines the RIM-116 rolling airframe missile with sensors similar to those in the Phalanx. It was developed as a last line of defense against incoming threats, including anti-ship missiles, aircraft, and small boats. The first prototype was tested by the U.S. Navy on the destroyer leader USS King in 1973. After improvements were made for better performance and reliability, the Phalanx operational suitability model passed its tests on the destroyer USS Bigelow in 1977. This model met all maintenance and reliability standards, leading to its production approval in 1978. The The first orders included 23 for the U.S. Navy and 14 for foreign military systems. The first fully equipped ship was the aircraft carrier USS Coral Sea in 1980, and the Navy began installing CIW systems on non-combatant vessels in 1984. The failing system is built around the 20mm M61 Vulcan rotary cannon, which the U.S. military has used on different aircraft since 1959. It uses a Ku-band fire control radar system to find and track targets. The system is mounted on a base that can quickly move up and down and side to side to follow incoming threats. This unit includes the gun, an automated fire control system, and other main parts, allowing it to automatically search for, detect, track, and engage targets using its computer-controlled radar. Its self-contained design makes it perfect for support ships, which usually don't have advanced targeting systems and have limited sensors. Failing CIW's units are sometimes nicknamed R2-D2 because of their round radar shape and automated function, resembling the droid from the Star Wars movies. In April 2017, Raytheon tested a new electric gun for the Phalanx, allowing it to fire at different rates to save ammunition. This new design replaces the pneumatic motor, compressor, and storage tanks, reducing the system's weight by 180 pounds while improving reliability and lowering operating costs. The United States has also invested in futuristic weapons to make these aircraft carriers more formidable. Some of these weapons include railguns and even laser weapons. A railgun, also known as a rail cannon, is a type of weapon that uses electromagnetic force to shoot projectiles at very high speeds. Unlike traditional weapons, the projectiles usually do not have explosives. Instead, they rely on their high kinetic energy to cause damage. A railgun has two parallel metal tracks and uses an electrical current to accelerate a sliding piece between them. This works similarly to how a homopolar motor operates. As of 2020, research has focused on using railguns as weapons because they can launch projectiles with much higher speeds compared to regular guns. Traditional guns can typically shoot projectiles at speeds up to about 2 kilometers per second, while railguns can easily reach speeds over 3 kilometers per second. This higher speed can give railgun projectiles a longer range and more destructive power, which depends on their kinetic energy when they hit a target. Since railguns do not need explosive propellants, the projectiles are also cheaper and safer to handle. However, railguns are still mostly in the research phase, despite many years of development. It is unclear if they will become practical military weapons soon. Any comparison between electromagnetic propulsion systems and traditional chemical propellants must consider factors like durability, availability, cost, and the complexity of the power supplies needed for electromagnetic launchers. How do these railguns work? A railgun has two parallel metal tracks, which is where it gets its name. One end of the rails connects to an electrical power supply, forming the back end of the gun. When a conductive projectile is placed between the rails, it completes the circuit. This allows electrons to flow from the power supply through one rail, across the projectile, and down the other rail back to the power supply. This flow of electricity makes the railgun act like an electromagnet, creating a magnetic field between the rails. According to the right-hand rule, the magnetic field moves around each rail. Since the electric current flows in opposite directions along the rails, the overall magnetic field between them pushes the projectile forward along the rails toward the front end of the gun. While there are forces trying to push the rails apart, they are held tightly in place so they do not move. If a current of 1 ampere flows through two long parallel wires 1 meter apart, the force on each wire will be 0.2 micronewtons. In general, the force increases with the square of the current and decreases with the distance between the wires. For railguns that shoot projectiles weighing a few kilograms and with a few meter-long barrel, very large currents are needed to reach speeds around 1,000 meters per second. A huge power supply capable of delivering around 1 million amperes of current can create a strong force that accelerates the projectile to speeds of several kilometers per second. However, these high speeds generate a lot of heat that can quickly wear out the rails. Railguns would need frequent rail replacements or the use of special heat-resistant materials. Experts agree that significant advances in material science are needed to create powerful railguns that can shoot more than a few times before needing new rails. The barrel must withstand this pressure for many rounds without breaking down. The power supply must provide large currents consistently and safely for a useful time. The most important measure of a power supply's effectiveness is how much energy it can deliver. As of December 2010, the highest energy used to fire a projectile from a railgun was 33 megajoules. Common power supplies for railguns include capacitors and compulsators, which charge slowly from other energy sources. The rails must handle strong forces during firing, which can push them apart from the projectile. If the gap between the rails and projectile increases, it can create arcs of electricity that damage the rail surfaces. This limited early railguns to only one shot at a time. The efficiency of a railgun is also limited by the inductance and resistance of the rails and power supply. Different rail shapes and designs are being tested, particularly by the U.S. Navy and other research institutions. The rails and projectiles need to be made of strong conductive materials that can withstand the stress of firing. Some research incorrectly suggested that the recoil force in railguns could be redirected, but careful analysis shows that recoil acts on the breech closure just like in traditional guns. The rails also repel each other due to a sideways force from the magnetic field, just like the projectile. They need to be securely mounted to avoid bending. Major improvements in material science are needed before rails can be made that allow railguns to fire more than a few full-power shots before needing replacement. Railguns generate a lot of heat from the electricity flowing through the rails and the friction when the projectile exits. This creates three main problems: melting of parts, safety risks for personnel, and detection by enemy forces due to the increased heat signature. Firing such a device requires materials that can handle extreme heat. If not, the rails and other equipment could melt or be damaged. Most railgun designs experience erosion of the rails with each shot. Projectiles may also suffer some wear, which can limit the railgun's lifespan significantly. While the railgun technology is under the research phase, the United States has made a lot of progress with its research on laser systems. Let's check out the features and capabilities of one. The United States Navy's High-Energy Laser Counter Anti-Ship Cruise, or HELCAP missile project, is getting closer to transitioning its developed technology into an operational system. Currently, one San Antonio-class amphibious transport ship is equipped with a 150-kilowatt Mark II Mod 0 laser weapon system demonstrator. Additionally, 8 Arleigh Burke-class destroyers have the optical Dazzler interdictor Navy, and one destroyer has the 60-kilowatt high-energy laser with integrated optical Dazzler and surveillance or Helios system. HELCAP is different from these systems, which are designed for counterintelligence, surveillance, and reconnaissance by dazzling or destroying unmanned aerial systems. HELCAP specifically targets anti-ship cruise missiles in a crossing scenario, meaning it can defend against missiles aimed at nearby friendly ships. The U.S. Navy started HELCAP in 2019 after the ruggedized high-energy laser Phase 1. HELCAP aims to address technical issues that laser weapons face, like advanced beam control, effects of atmospheric turbulence, precision tracking in cluttered environments, and automatic target identification and aiming. The results from HELCAP and years of technology development will come together to create the laser weapon testbed central to HELCAP. This testbed will use a 300-plus kilowatt laser developed under the High Energy Laser Scaling Initiative, which has funded teams to deliver these powerful lasers. The laser will be combined with a prototype beam control system created by the Navy and integrated with a power and cooling system. The LWT will be tested at the White Sands Missile Range this year, and the initial test will focus on the system's beam control, tracking, and optics performance. Afterward, it will be tested against increasingly complex targets, starting with stationary ground targets, then moving targets, and eventually low-cost unmanned aerial targets in cruise missile surrogates. Once completed, this program will help improve future systems based on the Surface Navy Laser Weapon System Increment 1. Currently, there are no plans for the program to leave behind any assets or prototypes for ship integration. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.